auto-generative or an auto-regressive neural network. Simple as that. It's a transformer-based model. It basically tries to take in some input and produce the following outputs based on the training data that it was trained on. There are some effectively sophisticated ways in which this is done. But a very simplistic version is basically where you feed in information and then you try to get on the other side information where it actually tries to say this is what it could be, the potential probabilistic sense of what could be the other side of the sentences or the phrases. So typically, if we have a model that is trained on poetry, then you would get something like roses are red, violets are blue, sugar is sweet. So things like that. For a code-based model, something like a code completion model. So typically, what you would see on like a GitHub Copilot, then you will typically feed things like for I is equal to 0. This would be again a Java-based syntax. Then it will try to fill in the rest. So things like that. The major challenge with LLMs is that it's basically large. So this is one major issue, is that if you are new to machine learning, I think then you are pretty much on a nice path now. But in general, if you've worked with machine learning before, we used to train models typically on a GPU, and then we used to deploy it. And then this used to take a lot of memory, and then typically we will think about inference time requirements and training time requirements, whether you need a GPU for inference or whether you need GPUs just for training. And we used to do different techniques for when you just use training level GPUs during the training, but not during inference, and so on and so forth. But in general, because of the problem with LLMs is not a problem, an approach, because of the number of parameters with LLMs, this challenge becomes quite large. So you cannot now just think about one GPU, but you would typically need 2 to 3 GPUs to simply just distribute the model and then even start to do some inference. If you're curious about doing typically, also running your own local LLMs, that is also possible with OLAMA and different variations of large language models that are open sourced, with Llama 3, with Gemma from Google as well. But in general, large language models are, as the name suggests, large, and this has its own challenges and issues that comes around with it. But in general, typically we're talking about large language models, which means that we're talking about text-based models here. Typically, you approaching tasks such as entity extraction, classification, summarization, sentiment analysis, translation, and so on and so forth. There are several areas which can be used, or can be LLMs can be applied for several other areas. Typically, in the earlier scenarios, what we used to do was we used to train a model for each of these tasks. We used to have a separate model for entity extraction, separate model for classification, or we used to train a so-called large model, language model for pre-trained model, and then we used to fine-tune it for different end-level tasks. So typically translation, sentiment analysis, and so on, so that we had a bit more context about the rest of the world. But these days, because of the scale of large language models, what we can do is we can pretty much have all of this sort of as an abstract within the same model itself. So we don't have to train specific models for each of these tasks, but rather we have a large language model, which can then leverage, or which we can leverage to actually solve each of the problems that we are trying to actually approach with. So the biggest advantage with LLMs, so we have said that there is a challenge, but what is it? Why are we even talking about this, right? So the biggest advantage is that prototyping becomes extremely fast. So why is that? That's pretty much because of the fact that you don't have to do this training. You don't have to do most of the issues that comes with typically with data and so on. And also the fact that with these models, now we have the advantage that we can have multimodal sort of like an approach. What is multimodality? Multimodality is where you have more than one model, typically text-based, image, video, audio. You would have seen these examples probably, or if you've not, then I will highly encourage you to go to ai.google.dev, and then you will be able to see this information as well for yourself. typically, we will also see an example here later, from a few slides from now, how we can also do that typically with Gemini as well. In general, this is the biggest advantage. Now we have a transformer which is now being trained for multimodal data. And what we can then do is we can feed these multimodal data, combine text, so not just the typical prompt, but also provide an image and then say, hey, what does this image talk about? So I will show you an example where I was able to actually extract information from a patent. So typically you feed a file with images and text, and then the Gemini was able to actually extract the information, summarize this, typically extract the information out of the patent application itself, and then say what it's actually each of the figure is talking about. This is what could be actually useful, and so on and so forth. But in general, so why is this important right now is that this helps in getting things out quickly. So you can test it out quickly. You can say whether you need to actually train things on larger data, newer data, and so on. But yeah, so I see there is someone who has raised their hand. Is there a question or a comment? Okay. All right. So yeah, feel free to post your comments as well or questions on chat. But if not, again, feel free to also unmute yourself in case you have an immediate question that you would like to be answer, you'd like me to answer. But in general, so this is the biggest advantage with these large models is that since it's trained with typically the internet of data, it allows you to quickly prototype and quickly fail. And this is where we come to, yeah.
Sir, can you explain the transformer? I've read like the Hugging Face
Mhm.
demo about transformer, but I couldn't understand like what do you mean by transformers?
So transformers are basically the model that typically that what happens is that, so if we get into the technical details here, we need a separate session purely for that. I can share a summary of what exactly the transform models are actually doing. So transform models are basically, attention-based models where it allows the model itself to actually take large amounts of text to actually solve different problems. So to say very simply, given that we have barely half an hour left, I can share like a paper with towards the end as a resource that you can go through. There are wonderful summarizations, wonderful visualizations of what exactly a transformer is doing. There is a paper called "Attention is All You Need." Which is also from Google. So this is actually a paper from 2018, which will give you an idea of what exactly the transformer is doing. This is where it started. So this is the reason why this works well is it's actually highly scalable. And this is one of the way in which OpenAI took the idea for the transformers for their initial ChatGPT with ChatGPT GPT-2 and then GPT-3 and so on, and then they scaled it up quite well. But this was a text-based model, and then came multimodal models. But yeah, so maybe I can share some resources which might help you in understanding this. But we will quickly look at, given the time constraint here. This is a short summary of what it is. It's a complex neural network model, which allows you to actually take in input and then have an attention-based model on it, and then get the output in for different tasks. So there are different neural networks for that actually leverage this type of like an architecture called BERT and Roberta and so on. But the classic one was called BERT, the BERT model. That's a bidirectional encoded representation model, a transformer. But yeah, so this is where I can share more resources, and then yeah, if you have any further questions, we can also chat offline. But right now, I will quickly come back to the Gemini discussions. I see another hand that is being raised. Does someone else also have a question?
I have a question. If we
Yeah.
use Gemini AI in our Python code,
Mhm.
so if we give the prompt to create image, what's he react?
Yeah, so we will look exactly at that. So this is where I'm actually coming to actually show. So you're talking about image generation, right? Or image processing, things to do with image as a model. This is exactly what we will be discussing over the next few slides. What are the variations? How can we do together with text? How can we do with video? How can we do with audio? And so on and so forth. I will share all of this information, and then you can also probably try it out yourself. But yeah, so this is exactly what we are going to come to. So with Gemini, there are three different types of models. The Ultra, which is the most capable model. Currently, it's in like a very short preview with people. The Pro, which is already available. I will also show you how the Pro actually looks like. Typically, this is the one that's going to be used for a wide range of tasks. And then comes the Nano. The Nano is a very efficient model for typically for on-device processing. This is also available through Android AI Core. So in case you are an Android developer, there is also a separate link that I can share with you that you can actually go to Android AI Core, and then you can actually get the Gemini Nano as well. So you can actually run the Gemini Nano on your device itself. So this is also possible. So typically also we're talking about Gamma now. So Gemini is different from Gamma. So Gamma is an open source model. But what happens is, Gamma is a bit more, it's very specific to text. And then so here it's currently available through, like I said, Olama is one source where you can actually get Gamma. So these are open source model. So not typically the open source as an open source where you can download the weights and then play with it, but there are some check on the license restrictions. Kaggle has a page where you can go and sign up for Gamma. So Gamma is different from Gemini. So Gemini is the large model that Google offers, typically via the Google Vertex AI or the Google AI Dev. And Gamma is the open source model. So this is something where you can typically also download with Olama, and then you can play with it on your, I actually have it running on my Mac. So it is actually possible to run, there are different flavors that you can run these open source models, typically the 7 billion model or a 2 billion parameter model. So Gamma is an open source or an open model or an open source model. It's an open model which allows you to do a lot of these tasks, but on a smaller scale. So what exactly happens? So the ecosystem itself, actually, it has like quite a few points to discuss. Today we will look at the Google AI Studio and Google AI.google.dev. There are typically other areas where you're talking about Gemini on the Vertex AI. So this would be for business customers. So if you're a startup, for instance, then you can leverage Vertex AI, where you will have a dedicated AI compute from Google Cloud. But on the other side, you also have, for consumers, you will have the application Gemini on the web, Gemini on Google App, and so on and so forth, through Gmail, through Docs. There are several examples for this. So where are we from, from where we were? So a couple of years ago, before ChatGPT was, discussed so widely, all of this, we were discussing about regression classification, how can we use machine learning to do forecasting, sentiment analysis, like I said earlier, image classification. So all of this was done typically with GPUs and with neural networks being trained on large GPUs. But what happens is then with generative AI, the conversation changed. So now we are talking about text and image generation. Typically, the neural network also rewriting a lot of these things. If you're working at, I'll show you an example as well for code rewriting. So you can provide it a piece of code and then ask it to write test cases as well. So this is also possible. So you can do summarization and so on and so forth. The type of the task that we use AI for now has actually become a bit more larger than looking at independent tasks like sentiment analysis and object detection, but rather we're talking about, given an image, what does this image talk about? So so you ask questions which are more descriptive about the image or the video, and then now you take a one step or two steps back, and then you don't have to worry about individual things like entity extraction or object detection or classification, but rather you think about a larger context of the scene or larger context of the video. Are these two videos similar? Do they have similar scenes? Are these actors similar in these videos? So questions like that have become a bit more, towards problem solving rather than towards the machine learning aspects. And the same come to also with multimodal generative AI. So with Gemini, what happens is the discussion sort of changed. So we don't just talk about text or video anymore, but we are audio or images, but we talk them together, as a context, together with automatic speech recognition. So you can, like I mentioned, so you can upload PDF with images and with text, and then it'll be able to come up with an answer about what this PDF actually contains, and in the context of the text, actually provide a point about why this, a figure that's provided in the text is relevant in that particular talks. So this is why this becomes, now we are talking about, over time we've actually gone to solve business problems, the problems which have a larger context. And this is why I wanted to actually sort of like not say do machine learning with with Gemini API, but rather we're talking about solving problems with the Gemini API. So yeah, there's a question: is predictive AI discriminative AI? So here, yeah. So in this case, yes. So we're talking about pretty much the case where we were able to do, AI, or I wouldn't say AI, machine learning, where we were doing this predictive analytics or predictive machine learning, where we were doing things which we were training on our own, but with also the context being a bit more smaller. But yes, so to answer your question, yes, so it was able to do all of these on a very small level task, and now we are doing it at a much larger scale and much larger scope. So coming straight to the point, we're already 15 minutes or 20 minutes in, getting started. So how do we get started? As I mentioned, go to aistudio.google.com, and then you should be able to generate an API key, test and save the prompts, customize the model, and then get starter code. So what will that look like? So this is how ai.google.com will look like. So this is also the point that I mentioned about the patent application that I was talking about. But in general, you should be able to, go, go to aistudio.google.com, and then you should be able to generate an API key. So if you click on Get API Key, you should be able to generate an API key. This being also a bit more. This is more like a password, so I will probably not click here, but in general, you can create your own API key, and then you can use it to create a new prompt, or you can also, in this case, so we will go through what all things that we can do, but you can see it can actually do several other things. The main advantage with this is the context size. So we will come to this point as well. You can also choose the model from the right-hand side. So here 1.5 Pro is available for me, but if you go to aistudio.google.com, you can check whether this is also available for you. All right. So I see a question. I want to learn prompt engineering. How can I learn? How can AI in MERN? How can I use AI in MERN? Anyone share a link of WhatsApp? Anyone can guide. So typically, with prompt engineering, there are several courses. I'm not sure what you're planning to, because you can go to deeplearning.ai. So deeplearning.ai is a course that's actually run by Andrew Ng. Andrew Ng is one of the pioneers of machine learning. You can go to deeplearning.ai to learn about prompt engineering. So prompt engineering basics, you can learn about prompt engineering in this course. So, and it's actually a wonderful resource. They provide several, from the basic until advanced techniques for prompt engineering. It would be available there. So I hope that I answered that question. You can actually, there are several resources. I can share more if you need. But in general, there are like now plenty of courses that are available where you can actually get the prompt engineering courses. Let me know if you cannot find them, and then I'll be happy to share more resources as well. So coming back to the point here, so we now went to AI Studio, created an API key, and then we will look at also what are the different things that we can do with it. So in general, yeah, this is like I showed you, it's typically you can create an API key, but what you can also do is you can also, as I mentioned, you can choose the model on the right, and then you can also, for instance, try uploading an image and then suggest a meal plan based by these three dishes. So things like that. The beauty of this, with the AI Studio is that once you finish your prompt and then once you see that the results are good, you can actually get the code for your model. So typically it could be in JavaScript, it could be in Python, it could be in any language. So I can show you exactly how that looks like. So in this case where I uploaded a PDF, it contains about 11,000 tokens. what I can do is I can also get the code. And if I get the code, it will tell me, okay, you have something in Python, and then it's go. This is how you basically do this. So it's very, very straightforward in understanding how you can actually do this. Typically, how do you extract the PDF? How do you actually chunk it? And how do you actually, feed this information and so on? So this is how it's actually super nice with Gemini, is that you can try everything in the same place, and then you can get the code as well that you can integrate directly into your application. This is where it's going to be really useful in actually getting everything into a single place. And also the nice thing is also that you see here, you can basically upload an image, you can video or an audio, or typically also a file. So this is where I would suggest you, uh, you know, if you're curious, go to AI Studio and then try it out yourself. These things you need to break, and then you need to try, and then you need to learn. So it might be nice to see these presentations, but I would highly encourage you to go directly to all of these places, to whatever is being said, and then try to learn it yourself, and then see what works, what doesn't work, and so on. So I see another question, as a fresh graduate study, a student graduate in data science, in curious about the advancements in Gen AI. A plus point for me or a setback? Is a setback. How do as a data scientist adapt to these changes? I would say as a data scientist, it does not matter. So these generative AI things are useful for people who are doing higher level business level topics. So so again, generative AI is not going to be the solution for everything. But yeah, in general, this would actually help you in solve most of the problems. It's going to, as a data scientist, it's going to make it easier for you in delivering the solutions quicker to the client as well. And given the the influence, given the hype around generative AI, I would suggest you to also see first. Generative AI would be if it actually solves the problem first, and then go to trying to see if you need to do other parts like fine tuning, which I will chat in a moment, and so on and so forth. Whether you need machine learning, whether you need to train your own data on your data, and so on. So yeah, as a data scientist, you are at a very high, you are at the forefront. Nothing is going to happen to data scientists. So you can easily learn these things, and then you should be able to apply this to most of the jobs that you are going to apply to and then work with. So absolutely no worries, even if you are a data scientist. There's also another question. Is machine learning part of data science? So this question is actually a very contextual question. So typically people will say data science is like a larger umbrella around. So machine learning is a part of data science, long story short. But there are some people who will say machine learning does not necessarily come within data science. But yeah, so
Can I ask a question?
yes. Mhm.
I ask a question in the upside. I made a prompt and this helped ChatGPT to access adult things and what it's look like bad, but I think it's good because it's the first step for me to make a good prompt. What do you think, sir?
What are you talking about? So which prompt are you talking about?
I made a prompt
Hmm.
around
Okay.
200 to 300 lines, which consist of
Okay.
many psychological things, and it can
Okay.
access ChatGPT to adult things like about
Okay.
what do you think? Is it good or not?
So typically, I'm not sure what you mean by other things here, but typically, most of so I will also show you responsible AI here. Most of ChatGPT as well as Gemini, these are all of them have safety settings. So as you see here, you will not be able to actually do a lot of these points about. I'm not sure. Again, I'm not very clear about what you mean by adult things here. If it is
Yes, yes.
purely about.
I made a prompt and I asked some things like adult things from ChatGPT, but it denied to answer me.
Yes,
But I made a
exactly.
prompt and it gave me. In first, he gave me warning, but in the last, he gave me the links. But
Yes.
when I tried this prompt in Gemini, uh,
Yeah,
he denied, and I tried so
exactly.
much. Yes, yes.
Exactly. So this is exactly the point here I wanted to share. So Gemini is actually really in conservative in that
Most
sense
cured.
because yes. So basically, most of the explicit content, dangerous content, all of this will be actually blocked. But you have a setting where you can remove everything. So you'll see basically it will tell you you are basically don't do this. It will actually tell you that you cannot do the don't try to change these filters. So it will try to, yeah, it will say I will give you a recommendation, maybe don't go completely off, but yeah, maybe make it a bit more and not too much. So yeah, so in general, say, the responsible AI is something that's a very big topic. We will come to that as well, but in general I would suggest probably not. I would leave it to you. I think if your application requires some sort of like these themes to be discussed, then yes, very well, you might use it. But you can actually change the filters to make it actually be relevant for your application. So this is what I will say. So yeah, it's up to you to use AI in whatever way you see fit. But in general, yeah. So there are ways in which you can reduce explicit content or basically leave or reduce the amount that your customer sees in the end. But in general, if your customer is expected or is expecting something like that, then very well you can simply just change the filters and then you can use it. So as I mentioned, so I think yeah, I think there was also one more question you want to learn. There was this person, I want to learn app development. So where can I learn? For app development, typically you can learn pretty much anywhere. There are like several, again, as I mentioned, there are like different courses, like Coursera is one. I'm not sure which app development you're talking about, if it is web application development or mobile application development. There are several courses where you can take for different tasks. So yeah, let me know where, but in general, Coursera should be able to tell you, um, you can actually find out most of the courses that might be relevant for you.
So please
Okay, for mobile
differentiate.
application. Mhm.
So please differentiate machine learning and data science. What exactly learn from doing data science, and what we learn exactly for machine learning
So
and deep
yes,
learning.
so yeah, so data science is basically where you are basically not just talking about this, with machine learning, you're talking about specifically points about how do you, look at the statistics about a model and so on and so forth. So basically, you look at the patterns in the model, and then you see where you can actually, how do you build a model. So this machine learning itself tries to actually think about these aspects. So with data science, what happens is you're talking about data as well. So which are the, you talk about data normalization, you talk about, data also comes into play together with. So this is why data science is a larger umbrella, talking about the holistic field of, where do you fetch data. So which are the, for streaming data, what happens, for, structured data, how do you process it. So things like that would be really relevant for data science. So in general, a data scientist is expected to also know about typically about data schemas. How do you build the most efficient schemas for a given task. What do you think about different ways in which you process the data to make it useful for downstream tasks like analytics, for machine learning, and so on. But in general, this is why data science itself is a larger umbrella than machine learning and deep learning. So deep learning is a very specific area. Machine learning is a larger, again, a bit more larger part. Deep learning is a bit more smaller, specifically talking about neural networks and how do you design neural networks to come up with answers for different tasks around text, around images, around audio, and so on. But deep learning is a bit more data. It requires a lot more data to train, and it requires a lot more compute. So the point about deep comes in the fact that there is actually a bit more number of layers when you design the neural network. While in machine learning is, like I said, it's a larger umbrella, covers also deep learning, but some people would also not agree to that. So in general, machine learning is a bit more older term for that includes also the classical techniques like SVDs, like the support vector, and so different points about the classical techniques that were used for machine learning. And deep learning is a bit more modern, where you use neural networks to actually accomplish different tasks. So yeah, I hope that answers your question.
I have a question.
Yes.
What algorithm ChatGPT use to check what I am talking about? Like sometimes I use wrong spellings many times, but he can
Yeah.
understand. What algorithm
Yes.
he can use to understand
So
what I am saying?
typically, so yeah, so typically ChatGPT uses so it's an algorithm itself is a deep. So here we're talking about deep neural networks, right? So we're talking about transformer architectures, several transformer architectures, which are also getting complex to understand here. The reason why it is able to, so the neural network is able to understand even incorrect or something that you spell your questions with spelling mistakes is because of the fact that the neural network itself is trained on larger data, large amount of data, which means that it should have seen your question, these sequence of words in a lot of contexts, which means that it can actually figure out even if you made a spelling mistake from the rest of the sentence, from the rest of the words that you actually made about what the spelling, the word, whatever the word that you made a spelling mistake on, it can actually figure out what you're spelling, what you were actually trying to mean in the end. This is why it is also able to make a much better idea of even if you made a spelling mistake. So yeah, I hope that answered. It is purely amount based on the amount of data it was trained on, and on the amount of information it will basically. It also has several billions of parameters than conventional neural networks, and this actually allows it to be a bit more resilient in the amount of in the mistakes that it can actually tolerate. So this is the reason why it actually works quite well, even if you make mistakes. All right, so I also see another question, where do you get started with machine learning after learning Python? So typically, again, like I said, there are like, you can go to Coursera. Coursera has great several courses. Udemy has great courses. But in general, courses are good. I would suggest you to take projects, take different problems that you actually have, and then try to solve these problems with whatever you actually try to, learn from, either your data science course or any of these courses, because it's going to be very difficult just if you do keep on doing courses. It's not going to be helpful, but instead if you take up a project, then you'll be able to contribute to the project. You also learn from contributing to it, and you'll be able to showcase what you actually did with the project. So in that sense, it will be actually relevant for you to actually come up with a sort of like a solution in the end, and also learn while you're actually trying to come up with the answer. But the point here is you can actually learn from like different courses like Coursera, deeplearning.ai. All of these places have different courses on machine learning. So there is absolutely no problem in actually trying to find courses for these. So I see someone also answer these questions. Yeah, Code Academy, different parts. I also see another question, able to answer, get an internship. So for internship, yeah, so these are, I think, very, so here, this is what I have said. So probably we can actually talk about this a bit more, maybe separately, because I think I see a sort of like a pattern here about how to do, what to do after sort of like a course. We can come to this separately. Maybe this is something that I can also show you where you can do as the next steps as well, and then it can actually help you in starting with something, showcasing your portfolio on your GitHub page. Typically, what is also good for people, especially after you finish your grad school or your your undergrad, once you're done with computer science or any of your your engineering degrees, typically it would be interesting for you to have a GitHub page if you're interested to get into IT or IT related areas. It would be great to have a GitHub page where you can actually upload different repositories where you showcase what you've done, and then you can actually show how this actually works and so on. But in general, yeah, that will actually be helpful for you. So when we come back to Gemini here, Gemini actually comes back to different ways in which you can interact with it. It's a REST API, so you can interact with it either using curl, if you're a typical command line based sort of like an interactive person, or you can use, of course, Python. Python is the most preferred. Front end developers would like Node.js. If you're an Apple developer, typically Swift, and the conventional Java, also developers also have Java SDKs. So all of these are supported. And as I mentioned earlier, This is basically also for enterprise application, enterprise consumers available through Vertex AI. Vertex AI has a Vertex AI bench, a model bench, and so on. We can also discuss about this separately. There is a complete course where we can actually talk about what exactly the Vertex AI also does. In general, okay, I think given that we have barely, I don't know, around 10-15 minutes of time, I will quickly go through what is prompt engineering, what is basic prompting techniques that you can use, and so on. What you can also try out is go to aistudio.google.com and then try to provide your inputs and try to also see what you get from AI Studio. So typically, as you know, prompting is basically giving an input and trying to get an output based on what your input was about. So typically you ask, write a poem about magic backpack, and then it is going to come up with an answer. What it is doing is it's taking existing trained data and then trying to come up with a new pattern based on the question that you're asking for. In general, what would also be useful is to see how structured data can be used. And then here is an example where you can use structured data to actually provide a structured table-like information as well. So if you're looking at how it looks like in code, so you see basically there are barely 4 lines of code. So what you're basically saying is, I'll also show you how this looks like. So you'll say Google or generative AI as Gen AI. Then you say, as a generative model, I want Gemini Pro. And then I say, write the first paragraph for a story for a magic backpack. And then the response is basically, it's because it's a REST API, we're just feeding this information to an endpoint. And then the endpoint is basically just giving a response. So it's a very typical HTTP request response. I also see there is a question about what is the AF the REST API and so on. How does it work? It works. It's a classic REST API. So basically, there are different ways in which you can interact with the API itself. But in general, you will have different endpoints to which you post this information, and then you get a response. It's very standard. So that way, as an IT developer, you have a very standard IT API reference, and then you know what is the request going to look like and what the response would be like. And behind the scenes, you can the model will change however they might want to change, but your application would not break because your input and the output would basically remain the same. The structure for the input, structure for the response would be effectively the same. So this allows you to actually build models which can actually change behind the scenes. You can provide regular updates. You can provide different parts where you can actually make the model better behind the scenes, but the user does not have to figure out how the developer team does not have to figure out how to consume your model. But yeah, so this is the main point about this. So I also got a notification that this call will end in 15 minutes. All right. So what are the potential paths one can master to have a career in AI? I will suggest try to do as many projects as possible. So try to go to an open source, go to GitHub. So there are also GitHub repositories with open source different. I can also share some projects. You can get there. You can try to contribute to them. That will be one of the biggest ways in which you can actually be noticed. Other people can notice you as a developer within the community. So I will suggest you to go and then try to do different projects within different open source repositories as well. But yeah, of course, to find a job, that's a different problem. That's a completely again, it's a chicken and egg problem. So you need to still, one way to, if you have the time, would be to contribute to open source projects or start your own project. So typically I had this problem of analyzing patterns. So I actually started working on this and then tried to use Gemini, and then I was able to showcase different points. Back in the day, I also trained different models for image classification, object detection, and so on, and made them available through my GitHub repository. So this actually helps in your potential employer also see that you have a lot of things to showcase on your GitHub repository. That actually brings you also some sort of like a credibility in that you actually know about this, and then you contribute to the community itself. So this actually gives you sort of like also community contribution as well. But yeah, coming back here, so we are coming back to, I think we have several points to discuss. I'm not sure if we will be able to cover all of these. The points that we're talking about is basically prompting. So here there is actually several best practices as well. I will share this slide after this discussion, after this talk, so that you can also go through these links, and then you can think about the safety settings, top K, top P. Top P is basically the top priority, the probability. Top K is basically the which are the top 3 responses, top 5 responses that you want. So these are different knobs and things that you can actually play with when you're actually trying to work with generative AI. It's very similar if you worked with machine learning and deep learning, where you play with learning rate, you play with the whether you have an atom learning sort of like a structure or so on. But in general, yeah. So this is basically, there are several things that you can actually work with. This is for prompting as well, it comes very handy. You will actually have best practices also available directly from ai.google. You should be able to also get this information from this page. It's a very nice collection of the best practices. So it's also updated regularly. So feel free to also go to this page and try to look at it. So when we come to content generation, so we are looking at different parts. So I think the classical way is, as I mentioned, generating code based on a user prompt. In this case, it's like the GitHub Copilot, where you say, I want a function in Python to basically, discuss with or rather interact with a REST API. So this is the endpoint, and it will basically come up with the REST API itself. So there are also several such examples where you can actually see for code generation. Typically, you will generate the data and then you will try to interact with it. Again, I won't go too deep into this, given that we have barely, I don't know, 5 minutes or so. This is going to be very helpful in code generation. So I will share these slides as well later on. But I think what is really useful, especially if you are an IT developer, or someone who works in software engineering, is basically the testing. So people hate writing test cases. So if your code is available, in general, or if you can actually feed it to a model like this, then you can write unit tests automatically. Be careful in not actually providing your data to your code to something like Gemini or with any of the large language models. Typically, because you're feeding it to all these cloud developers, so you have to treat your code, if it's especially you're working for a company. You have to be careful with where you feed the code. But in general, so forget about that. Where it is actually really useful is if you can use this. If you have a Python code, you can actually get tests done automatically. So it actually comes up with beautiful tests, very well documented tests. So these are actually extremely valuable, especially if you're working on an open source project. So this actually helps in actually writing test use cases that actually works well, and then it actually thinks about all the corner cases and so on and so forth. So I would not go. There is a very interesting also search example that I will show you directly. So this is an example where you can feed your own file, and then you can actually try to ask it questions. So this is something that I will show you in a minute, where we can actually see how it actually looks like. But in general, as I mentioned before, so Gemini Pro has about 32,000 input tokens. Gemini 1.5 has 1 million tokens. So this is what I also showed on the other tab, where I had this exact thing in action. So in this particular scenario, if you look at my page, so you will see that it actually says it's 1,048,576 tokens. So this is the number of tokens that it can process to basically come up with an answer to your question on either if it's a file or if it's basically a follow-up question, things like that. The 1.5 Gemini Pro has really useful sort of like a bandwidth that you can work with. All right. So,
which libraries we learned before TensorFlow?
So all of this is, as I mentioned, these are all API calls. So this has nothing to do with TensorFlow. This has nothing to do with machine learning. So these are basically, as I mentioned, end-to-end problem-solving tools. That's it. So machine learning comes in specifically when you want to have a specific problem that even the large language models cannot solve. So in general, don't approach a problem as a machine learning problem. So approach the problem where you see, if machine learning fits, then you use machine learning. Otherwise, most of the cases, especially in the industry, you don't need machine learning at all. Most of the cases, typically you will be able to understand as if you understood the problem well, then you will be able to actually help in actually you should be able to try to figure out an answer in most cases with pure data engineering, pure data rules. But in general, if you think that, or if you think that there is no other way, that you need sort of like a machine learning, deep learning, only then will you actually try out, for instance, like a generative AI based approach typically, and then you go to training your own model. Otherwise, you don't go to any of this on your own, because it's more time consuming. You need to also maintain it over time. There is also different concerns about data regression, model regression. So things like that will come into discussion. You need to figure out if it's actually really worth the time and investing in all of these topics. But yeah, that's a completely different discussion. In general, I would suggest to first explore generative AI if it's possible, and then go into like training your own model or exploring the model if you have the data, if you have enough data. So if you have large amounts of data, then deep learning would also be helpful. But in general, machine learning would help in most of the cases if it's barely just a simple classification. In those scenarios, even these generative AI based methods would be actually really useful. So again,
Sir, can
this is
you
again. Mhm.
sir, can you share your roadmap to your job from your student life to job? What your qualification and what you did?
So I basically did my undergrad in computer science engineering, and then I did a 4-year engineering course, and then I did a PhD in computer science as well, in computer engineering. Around my topic was around unsupervised machine learning. But yeah, so back then, or this was again about 8 years ago, I finished my PhD. So this it was a necessity that you need to actually have a doctorate. But in general, these days you don't need these approaches. So, and I worked in different places. I worked for different companies before. I actually have worked for close to four or five different companies. But in general, so what would actually be helpful is, as I mentioned, trying to work with different projects, open source projects. Try to contribute to as many projects as possible. Ping me if you have any questions on, where if you need any support on finding these projects. I can share a list of projects that might be helpful for you. But in general, it actually helps in, supporting open source projects, and gets you also like sort of visibility outside. So the TensorFlow project is one thing. You can actually do different, you can do different projects with different people as well, so that you can contribute and then learn in the meanwhile, and then you can see different things, how different things work, and then you can put together all of these together when you're actually applying for a new job. In general, yeah, so I would suggest, so my path was also a bit more, on the computer science. I was actually a bit more lucky. But for expert, again, for a Google developer expert is more about doing community enablement. So you need to provide talks, you need to talk to people, you need to enable people with different technology. So there the discussion is a bit different. So it's got nothing to do with it's got not nothing to do, but rather there you don't need qualifications. You basically have to understand different concepts, and then you need to teach people as an expert for you to actually give these sessions. How would you want to make them understand? How can you make all of these topics easy for people to consume? So there is a different sort of like for as a job, it's a different thing. As as a developer expert, you have a different profile altogether. But yeah, so I also see another question: is it better to learn web development before learning AI machine learning? So these are two different. I wouldn't say these are completely two different parallels. You can actually learn web development as also an AI developer or a machine learning developer or engineer. Yeah, so like I said, so you can actually leverage web learning or web application development. I actually use I do my web development as a machine learning sort of like an engineer. I do the other way around as well. So both of this has nothing to do with each other. So you can actually do web development as a machine learning engineer. You can learn machine learning as a web developer as well. So it has no impact on one another.
Sir, how much data structure and algorithm is important for machine learning and data science?
So it depends on the project, right? So it depends on the problem that you're working on. So if it's a problem that's actually not too big, then generally you will be able to get away with small amounts of data. So if you're talking about image classification, that's a very simple example. Image classification requires a lot of data that you need to actually provide, and typically you need to also have access to large of compute because of the fact that image processing takes a lot of compute. So in general, so again, it depends on the amount, it depends on the problem that you're working on, and it depends on the type of. So in general, with generative AI, the amount of data that you require becomes significantly less. You can sort of get solutions working out of the box. But with machine learning and with deep learning requires a lot of data. With machine learning, you can get away with sort of having not so much data. Again, depending on the the project that you're working on. All right, I think we are on the other side. I'm just walking through function calling here. So function calling is a bit more, I think probably I can show you an example which might actually, how do you develop your own search, sort of like a system on your own. So
Sir, I
here,
think your screen is not sharing at the moment.
okay. All right, so thanks for letting me know. Probably, I think we have barely 2 minutes left. But yeah, so all right, so yeah, this is the screen now. Again, I hope you are able to see my screen. So yeah, this is the Colab. So I don't know how many of you have used Colab before, but Colab is a very nice interactive environment which allows you to run compute on Google's infrastructure. So what we are doing is we can leverage Google's API key. I will share this notebook as well together with the slides. You can actually do a search. So for example, I just did a search here. What are the major components of an electric car? What it does is it basically builds a component. So you'll see different, it like acts like an agent. It actually goes and searches different pages, and it comes back and says, okay, these are the major components. This is what is useful, what will fail. So you can actually build. So this is just to show an inspiration on what you can actually build. So you can actually build an end-to-end search system as well. You can provide it with data, and then you can also make it actually try to feed this. You can feed this data, and then you can ask questions about this data as well. So there is another example where you can build a sort of like a function call. Like you can actually ask interactive natural language based questions, and then this is also another example of building a bot. So this is an interaction with Python as well as with functions that are built on Python. So I get a notification that the call will end